Hello everyone. Today we will study linear transformations, orthogonal transformation, orthogonal matrix. This is my lecture number 3 on matrices. I would like to request to all of you to subscribe channel on engineering mathematics to get latest updates and videos on it. First we will see linear transformation. For that, we consider y1 which is equal to a11 x1 plus a12 x2 and so on up to a1n xn. y2 is equal to a21 x1 plus a22 x2 and so on up to a2n xn. In this way, ym is am1 x1 plus am2 x2 and so on up to amn xn. Here a11, a12, all aij are constant. So we can write this system of linear equations in the matrix form as y is equal to ax. Here matrix A is called as matrix of the coefficients and it is a11, a12 up to a1n, a21, a22 up to a2n. In this way, am1, am2 up to amn. X is called as matrix of unknowns. It is x1, x2 up to xn. And y is column matrix y1, y2 up to yn. First we will see properties which are important properties of linear transformation y is equal to ax. If determinant of A is 0, as we are considering A as a square matrix, then A is called as a singular matrix. And linear transformation y is equal to ax is called as a singular transformation. On the other hand, if determinant is not 0, then we say that A is non-singular matrix and linear transformation y is equal to ax is called as non-singular transformation. If y is equal to ax transforms x1 square plus x2 square and so on up to xn square into y1 square plus y2 square and so on up to yn square, then it is called as orthogonal transformation. And in this case, matrix A of transformation is called as orthogonal matrix. Next property is, if A is orthogonal matrix, then we have A into A transpose is equal to A transpose into A is equal to I. This property is very important while dealing with the problems. If A is orthogonal matrix, then its inverse is A inverse is A transpose. So inverse of matrix is its transpose. If A is orthogonal matrix, then magnitude of each row and column is 1 and determinant of A is either 1 or minus 1. So determinant of A is plus minus 1. With this basic results, we now solve problems based on this. Problem number 1. Given transformation is y is equal to 211, 112, 10 minus 2 into x1, x2, x3. Find the coordinates of x1, x2, x3 in x corresponding to 1 to minus 1 in y. So we have given linear transformation y is equal to x. To solve this problem means we have to find values of x when y values are given. So we have given linear transformation y is equal to x and matrix A is 2 1 1 1 1 2 1 0 minus 2. Now to find value of x from this equation, if you multiply it by A inverse, means pre-multiply by A inverse. So we get A inverse of y is equal to A inverse of A of x and we know A into A inverse is I. So A inverse y is x, means x is equal to A inverse of y. And To solve this problem means we have to find value of x. Means we have to use this particular formula. So to find x, we need value of A inverse. And we know A inverse can be obtained by adjoint method. And formula is 1 by determinant of A into adjoint of A. So first we find determinant of A. This is determinant of the elements 2, 1, 1, 1, 1, 2, 1, 0, minus 2. And that is, if we expand it in the form of first row, it is 2 into minus 2 minus 0. Minus 1 into minus 2 minus 2. Plus 1 into 0 minus 1. So that gives minus 4. This product is plus 4. This product is minus 1. So finally we get this value as minus 1 and it is not 0. So we conclude that A is non-singular matrix as determinant of A is minus 1 which is not 0. Means A inverse exists. So we find minors. To find adjoint of A we need minors and cofactors. So M11 is called as minor of first element and minor can be obtained by deleting rows and columns in which that element belongs. So I want to find minor of this. It belongs to first row. It belongs to first column. So just neglect first row and first column element and you will get lower order determinant and its value is called as M11. So M11 is minus 2 minus 0. So that is minus 2. M12 is minus 2 minus 2. That means minus 4. M13 will be 0 minus 1. That is minus 1. M21 means it is minus 2 minus 0. So that is minus 2. M22 means it is minus 4 minus 1 means minus 5. M23 will be M23 will be 0 minus 1 which is minus 1. M31 will be 2 minus 1 is 1. M32 will be plus 4 minus 1 is 3. And M33 is 2 minus 1 is 1. So we get minors of every element Mij. And then we find cofactor A of every element. So that is Aij, which is minus 1 power I plus j into Mij. So whatever minus we got, we multiplied by minus 1 power I plus j. Here I represent in which row that element belongs and j means in which column that element belongs. So this way we find adjoint of A which is transpose of a cofactor matrix. So we find Aij and we just take transpose of those elements and we can easily verify adjoint of A as this minus 2 to 1, 4 minus 5 minus 3 minus 1 1 1 and A inverse is 1 by determinant of A and determinant of A is minus 1. So that's why it is minus of this matrix. So it is 2 minus 2 to 1, 4 minus 5 3 minus 1 1 1. If you multiply this minus sign inside you will get this. This 2 minus 2 minus 1 minus 4 plus 5 plus 3 minus 1. It is plus 1 minus 1 minus of minus 1. So it is plus 1 then it is minus 1 minus 1. So x is A inverse of y is A inverse is this into y values are given as 1 to minus 1. So if you solve this product it is 2 first row this column, this of this first row and first column. So it is 2 minus 4 is minus 2 plus 1 is minus 1. Then second row this column minus 4 plus 10 is 6. Then minus 3, 6 minus 3 is 3. So it is this of this 1 minus 2 is minus 1 plus 1. that is 0. So corresponding values of x are -1, 3, 0. When y values are given as 1 to -1 corresponding to the given transformation. So that is the answer of this problem. Problem number 2. Verify whether the following matrix is orthogonal or not. Where A is given as 1 by 3, -2, 1, 2, 2, 2, 1, 1 minus 2, 2. If orthogonal, find its inverse. So we have given matrix A and we have to verify whether A is orthogonal or not. As we know, property of orthogonal matrix is A is said to be orthogonal if A into A transpose is equal to A transpose into A is equal to I. So actually we take product A into A transpose. 1 by 3 into 1 by 3, that gives 1 by 9. A is given as this matrix. A transpose, how we write? We write first row as the first column. So it will be -2, 1, 2, first column. Second row, second column. So it is 2, 2, 1. Yes. Then third row, third column. 1 minus 2, 2. And we find product. So it is 1 by 9. Minus of -2 means +2. Into 2 means 4. Then it is +1, 5, +4. That is 9. Then first row, second column. -2 +2 that gives 0. First row, third column. -2 -2 +4 that gives 0. Second row, first column. It is -4 +2 that gives 0. Second row, second column. 4 +4 +1 that is 9. Second row, third column. 2 -4 that gives 0. Second row, second column. It is 4 +4 +1 means 9. Second row, third column. It is 2 -4 +2 that gives 0. Third row, first column. It is -2 +4 that is 0. This of this is 2 -4 +2 that is 0. Then third row, second column, which is 2 -4 +2 that is 0. Then third row, third column, 1 +4 +4 is 9. So if you multiply inside by 9, we get 1 0 0 0 1 0 0 0 1, which is identity matrix of order 3. So A into A transpose is equal to I, and you can easily verify A transpose into A is also I. So we conclude given matrix A is orthogonal, and by property of orthogonal matrix, A inverse is A transpose. So it is 1 by 3 of this matrix. So it is 2 with -2, 2, 1, 1, 2, -2, and 2, 1, which is final answer of this problem. Now we go to next problem. Problem number 3. Determine the values of A, B and C if A is equal to 1 by 3, first row, 1 to A, second row is 2, 1B, and third row is 2 minus 2C is orthogonal matrix. So we have given matrix A and we have to determine values of A, B, C. We know property of orthogonal matrix is A is orthogonal if A into A transpose is equal to A transpose into A is equal to I. So we actually take the product A into A dash or A transpose means 1 by 3 into 1 by 3 is 1 by 9. So it will be A is given as this 1 to A, 2 1B, 2 minus 2C, and A transpose we write first row as the first column. So it is 1 to A. Then second row as a second column, 2 1B. Third row as a third column, 2 minus 2C. and we actually find this product. And obviously by this property it is identity. So it is 1 0 0 0 1 0 0 0 1. Now we find this product. It is 1 by 9. Then first row, first column is 1 plus 4 plus a square, means 5 plus a square. First row, second column, it is 2 plus 2, 4 plus ab. So it is 4 plus ab. First row, last column, it is 2 minus 4 means minus 2 plus it is ac. So it is second row, second column is 2 plus 2, 4 plus BC. Then second row, second column 4 plus 1, 5 plus B square. Second row, third column 4 minus 2 is 2 plus BC. So third row, first column is 2 minus 2 is minus 4. Yes, 2 minus 4 means minus 2. Then it is AC. So minus 2 plus AC. Then third row, second column 4 minus 2 is 2 plus BC. And this row of this column is 4 plus 4, 8 plus 6. That is 1 0 0 0 1 0 0 0. So we get from this 1 by 9 of 5 plus a square is 1. That gives 5 plus a square as 9. So that gives a square as 4, means a is plus minus 2. In a similar way, 1 by 9 of 5 plus b square is 1. That gives 5 plus b square as 9. B square is 4, means b is plus minus 2. Similarly, 1 by 9 of, if you consider diagonal element, 8 plus c square is 1. That gives c square is 1, means c is plus minus 1. You can easily get this. Okay. Then we have a is 2. Then if you substitute a as 2, 4 plus ab is 0. That gives b is minus 2. And similarly, when we substitute minus 2 plus ac as 0, that gives b is minus 2, a is 2, that gives c as 1. So for a is minus 2, when a is minus 2, 4 plus ab is 0, that gives b is 2 and c is minus 1. So we get pair of the values. I mean to say a is 2, b is minus 2, c is 1. A is minus 2, b is 2 and c is minus 1. With this problem number 4, determine values of a, b and c if matrix A 0 to B, C, A, B minus C, A minus B, C is orthogonal matrix. On similar way of like last example, as we know, A is orthogonal matrix, A into A transpose is I. So we actually take the product A into A transpose, where A is 0 to BC, A, B minus C, A minus BC, and it transposes first row as a first column. Yes, this as a this column, this row as this column, and third row as a third column. So we get this, and that is equal to 1 0 0 0 1 0 0 0 1. Now if you simplify this product, we get first row first column, that gives 0 plus 4b square plus c square, means 4b square plus c square. First row second column, that gives 2b square minus c square. First row third column, that gives minus 2b square, yes, minus 2b square plus c square. Then second row first column, that gives 2b square minus c square. Then second row second column is a square plus b square plus c square. Yes. then second row, third column, a square minus b square minus c square. So we get this a square minus b square minus c square. Then we have third row, first column is minus 2b square plus c square. Then this of this a square minus b square minus c square. Then third row, third column is a square plus b square plus c square. And that is 1 0 0 0 1 0 0 0 1. So we have 4b square plus c square is 1, that gives, and 2b square minus c square is 0 from this. That gives 2b square is equal to c square if you solve this equation number. And if you substitute that value in 1, we get b square as 2b square as c square. So that gives 2c square plus c square is 1. Means 3c square is 1. That gives c is plus minus root 3. And 2b square is equal to c square. If you substitute value of c as 1 by root 3 means c square is 1 by 3. So b square is 1 by 6 means b is plus minus root 6. And a square minus b square minus c square is equal to, yes, 0. That gives a square is equal to b square plus c square. And we have got value of c as 1 by 3. So c square is 1 by 3. And we have value of b as 1 by root 6. So it is 1 by root 6 square means 1 by 6 plus 1 by 3. This value is 1 by 2. That gives a as plus minus root. So this way we get values of a, b, c, as a is plus minus root 2, b is plus minus root 6, and c is plus minus, a is plus minus 1 by root 2, b is plus minus 1 by root 6, and c is plus minus 1 by root. So with this we can solve these problems just by taking magnitude of every row and every column as 1, but you need to solve by using product also sometimes. Sometimes you may get directly values of ABC just by using property of determinant, property of orthogonal matrix as magnitude of every row and every column as 1. So I am giving one more problem for your practice. Try to solve this. Determine the values of, you may note down, values of A, B and C if 0 to BC as a first row, AB minus C as second row, and A minus BC as a third row. This matrix is orthogonal. So we have to determine values of ABC if given matrix A is orthogonal. You may note down this problem and you may try on similar lines as we already solved few problems based on this, and you may verify your answer as A is plus minus root 2, B is plus minus root 6, and C is plus minus root 3. Thank you very much for observing this particular video. I wish you all the best, happy learning, and thank you.